Now that we've done some basic solving trig problems, we're going to learn how to apply it with word problems. This is on the back of page 134 in your notebook. One thing I want to remind you from geometry is something called the angle of elevation. So the angle of elevation always comes from a horizontal. And usually people will get the angle of elevation placement correct. But you also have something called an angle of depression. And an angle of depression is also always from a horizontal. Which means if I have a problem that involves an angle of depression, because of alternate interior angles, the angle of depression is congruent to the angle of elevation, which is important because usually I've drawn this bottom triangle when I sketch a example for a word problem, and we always want to start with sketching a picture. So your angle of depression and your angle of elevation are congruent. They're the same thing. So let's look at the first problem. A monument stands on level ground. So once I start there, I have my level ground, and I have some sort of monument. The angle of elevation to the top of the monument taken at a point 405 feet away is 32 degrees. So we're somewhere on the ground away from the monument. So this is 405 feet, and my angle of the elevation that goes with the horizontal. Find the height of the monument, so that tells me what I'm solving for. And if I label H, O, A, I have something at O and something at A, which means I'm going to use tangent. So tangent of 32 degrees equals x over 405. Tangent of 32 and then we will multiply by 405 on both sides. So x equals 253.1 feet. A boy flying out a kite lets 150 feet of string out and makes an angle of 64 degrees with the ground. If the string forms a straight line, how high is the height above the ground? So here what you want to think about is that I have my person, right? And a kite goes out to the side. It does not go straight up into the air. And so the string of the kite is actually the hypotenuse of my right triangle. It says that it's making a 64-degree angle with the ground, and how high is it above the ground? So we draw our picture, label H, O, A. I have stuff at O and H, so I'm going to use sine. Sine of 64 degrees equals x over 150. Sine of 64 is 0.899. And multiply by 150 on both sides. And our unit is feet. A person in a balloon, which is 2,000 feet above the airport, finds that the angle of depression of its ship out at sea is 21 degrees. So you have this person in a balloon, and that is 2,000 feet up in the air, and the angle of depression to a ship is 21 degrees. We want to find the horizontal distance between the balloon and the ship. Now, notice I haven't labeled where angle of depression is. Angle of depression is actually outside the triangle I just drew. But using alternate interior angles, basically making this little zigzag here, I know that this angle is congruent to the angle of depression, and that would make it 21 degrees. If I label HOA, that means I'm going to be doing tangent. So tangent of 21 degrees equals 2000 over x. So I'll end up doing x equals 2000 divided by tangent of 21 and get 5,210.2 feet, or about a mile. Last, an airplane climbs at an angle of 11 degrees with the ground. Find the distance it has when it has attained an altitude of 400 feet. So, an altitude of 400 feet is going to be talking about height. And I'm going to say that this is talking about the distance it has traveled. I'm going to think that means a flight distance. So where is your plane flying? Your plane is flying on the hypotenuse. So we would label our HOA. So O and H is where I have my information. So sine of 11 degrees equals 400 over x. So sine of 11 degrees times x equals 400. Divide by sine of 11, and I could have found sine of 11 already, whichever order you do it. If it wanted the adjacent side, it would have asked for the ground distance, and still feet.